Our next speaker is Amihai. Amihai is a private security researcher here from Israel, homegrown. He specializes in malware and reverse engineering. He loves doing vulnerability research. And he's going to present us a very interesting talk of how he basically hacked his city. Do we still have it?
10 more seconds.
So we need still more 10 seconds. I want to remind you that we all are suffering from the extreme hotness in this room. And we hope that the air conditioner
Need some water?
Not yet, I need some
Anyone
whiskey.
need some water, feeling like they're getting dehydrated?
Sorry, it's already my second shot today, and they want to be my second time in Bar Gets Me Drunk before a talk. Anyway, thank you for coming for my talk about how I hacked my city. A little bit about myself. My name is Amihai Neiderman. I'm a security researcher from Israel. I work for a company called Ecos Technologies. And on my free time and sometimes work, what I usually do is vulnerability research. So a little bit about what we're going to have today. The talk today is going to be a walkthrough. I'm going to take you through the steps in the research that I did. I'm going to take you through all the problems that I had and how I solved them. So the best way to do it, just let's start doing it. So there I was driving my car one day, and I saw this icon that you see here. And for those of you who don't know, this means there is an open public Wi-Fi somewhere around me. And I thought it was pretty weird because I was driving my car. I wasn't close to any of the buildings around me. And I thought, well, maybe it's one of those buses with Wi-Fi on them, but I was the only car on the road. So I connected to that Wi-Fi. It was called Free TLV. Apparently, Tel Aviv started working on installing Wi-Fi hotspots around the city. And I live somewhere around here on that red arrow. And I probably picked up one of those hotspots when I was driving. Now, I have a really bad habit of mine. Whenever I connect to a public Wi-Fi, I usually go to whatismyip.com and check what is the external IP that I get. This is an actual print screen from that day. Now, what is it good for? Let's say there is this cinema place called Yes Planet in Tel Aviv. And if you connect to their Wi-Fi and you try to go to the admin page of their router, then they block it from the inside. But if you go to whatismyip.com, get the external IP, disconnect from the network, and connect it through your data connection on your phone, then they didn't block it from the outside. The username is admin, and the password is yesplanet with a capital Y, capital P. So,
Two-factor authentication?
yes. So I took this screenshot from my phone, and when I got home, I did the only reasonable thing you can do. I started port scanning it, and I saw port 443 is open. Now, that's cool, because I have an IP address. I'm not sure what it is. And there is a port open. So I went to that port, just surfed it to this port on HTTPS. And I got this page, something about captive. I just clicked on proceed anyway. And I got this login screen of a company called Peplink. Does anybody here ever heard about this company? Ever seen this login screen? Nope. So did I, never seen it before. And I was pretty bored, so I started messing around with it. I tried admin, it didn't work. I tried root, didn't work. Tried all kind of weird stuff. Tried some SQL injection. Of course, didn't work because it was in 2006. And I really wanted to mess around with it, so I still didn't know what that thing was because I only had an IP and this thing. So I tried looking at the HTML. It revealed nothing except for this login page, and the company is called Peplink. I looked at the headers, nothing. There was even a web server name. I tried running nmap with OS fingerprinting. It just returned it's a generic Linux. So I basically knew nothing about it. So I went to the manufacturer's site, to peplink.com, and the first thing I saw was this, unbreakable VPN. That's the first thing I saw. And I really like to break stuff. That's what I usually do. So now I'm really interested. And bored, so it's great. I found something to do for the rest of the day. And in Barton we put this. So I made this really simple plan in my head. I said, well, and some of the stuff I tried to explain my girlfriend, well, she's now my wife actually. I tried to explain her what I was doing. So I thought, well, I'm going to download the firmware. I just going to start reversing it. I'm probably going to find a vulnerability, and then I'm going to exploit it, and, well, it was a day well spent. But I wasn't sure which firmware to download, because this company makes everything. They make stuff with buses, stuff for defense, tanks, communication, mission-critical VPN for emergency communication. I'm not sure what it means, but they have a lot of stuff. So I thought, well, just go and download everything. But I have some like 5,000 different firmwares, so it wasn't reasonable. It wasn't practical. So I went to the index CGI and found something pretty interesting. There was a HTTP header called HTTP last modified, and it said it was last modified on May 2013. Now, usually in CGI files are, well, most of the time, CGI files are compiled. So I guess the last modified time was the day they compiled it. So I went to their site and checked all the firmwares and when they were compiled, and it was consistent with the version 5 of their load balancer series. So I guess, well, maybe it's a load balancer. I looked, this is the product. They have a couple. They have the balance 380, 580, 710. I'm not sure what the differences are. And so just started downloading all the firmwares for the load balancers from that time. And I started from the top, from the 380. That's supposed to be the high-end load balancer. And it was just a zip file containing a binary file with some strings in it. Nothing really interesting. So I changed my plan a little bit. Now I have the second version of it. Now I have to unpack it. Then I have to find the right version after I unpack all of them. Then I can reverse it and exploit it and, like, you know. So I use a program called Beanwalk. For those of you who don't know, Beanwalk is like a really cool program. What it basically does, you give it binary files, and it uses all kind of heuristics and looks for magic numbers to extract from a binary, a firmware, or something you can work it with, like a file system. And you can download from here. But basically, that time, all I knew about Beanwalk was like a mystery box. You give it a binary at one end, you get a file system on the other end. And if somebody will ask me to make like a tutorial for Beanwalk, I could give something like this. So I ran it with Beanwalk -e, it means just auto-extract, and I got a useless 7-zip files. Well, that's a fail. And I didn't want to find out why it failed, so I just moved on to to some other firmwares, tried the 210, 310. They came in a single file. Ran it and got a SquashFS file system. That's cool, because SquashFS, if you don't know, it's a compressed file system. It's a read-only file system. It's really popular on live CDs, routers, usually in places that you don't have a lot of free space, that the file system doesn't change a lot. And so it's pretty common. And the way to uncompress SquashFS is using a program called unsquashfs. So I ran it. It told me that it's a valid SquashFS 2.1. And that's pretty old, but it's also pretty common for routers, for those of you who try to mess around with stuff like that. It says the creation time is the end of April. So no, it's probably not the right version, but it's pretty close. And it says that data is compressed. But when you tell it to uncompress it, it just crashes and write read on file system failed because end of file. So what the fuck? So what went wrong? The super block, can you see it? Because it looks pretty bad from here. The super block sounds legit. It's a 2.1. The creation time is also legit. About the compression, we can argue about that. And there is this ancient tale around the internet that says there is a SquashFS compiled with LZMA, which is not very common, apparently. And maybe I just don't have the right unsquashfs. And I actually checked my unsquashfs, and it can only decompress gzip, LZO, and xed, no LZMA. So I looked around the internet, and I found something called FMK, the Firmware Mod Kit, just a collection of scripts and all kind of programs and utilities that lets you do a lot of stuff for firmwares. And it also have unsquashfs with LZMA. So I compiled it, ran it, and got a segfault. Shit. So I was looking at the code. I thought, well, I'm going to fix their bug. Then, first of all, I can get like a patch in an open source project. Going to be really cool. I'm going to help somebody today. And then I can unsquashfs my file system. So I was looking at their code, it has a lot of bugs, but my conclusion was that my file system wasn't compressed with LZMA. Then I said, fuck it, I didn't fix any of the bugs, and I don't know, I'm selfish. So it was time to find out what's in the box. What does Binwalk do all the time? Because Binwalk prints a lot of stuff while it's working, and I never looked at it. And said, well, it's time to find out what the hell this thing does. And I looked the first line, that's all I had to do. And on the first line it says there is a X2 valid file system on 180 bytes offset from the start. And X2 is like one of the most popular file systems in the world, and probably in Linux. And I'm not sure why I didn't decompress it, but it's there. So I just wrote this line of bash. I dumped it from this offset, mounted it as an X2 file system, and got this really nice file system. Inside of it, there was something called root disk SFS, which is just the squashfs. I ran unsquashfs on this, and got all the important files that I want. I got all the CGI files. I got the web server, basically all the important stuff that you want to research. So now I need to find the right version. I was sure that, well, I thought, well, maybe it's not the right version. Maybe it's close enough. I need to know what's the difference between the one in my, well, let's call it my target, the one in the Tel Aviv Wi-Fi, and the one that I just managed to open. So what I did, I looked at all the CGI files that I managed to extract from the file system. It was just in one of the folders in CGI bin manga. You can see the path on top. And I looked at all the CGIs, and all of those are supposed to be accessible from the internet. So I just wrote this little script. That's not the actual script. That's why it says something different here. What it does just iterates over all the CGI files from that file system and checks the original one, the original load balancer in the Tel Aviv city, if it has all those CGIs. And you see that one of them, the upload speed test, returned something which is, we returned the 404. I actually wrote 400 here, because it's just a mock-up of the original one. And that means that it's probably not the same version, because it was missing a couple of, well, maybe just one CGI files. So I went to the 380. I was pretty sure right now that the 380 is the one that they're using over there. And I did the same thing. I dumped it from that offset, mounted it as an X2 file system, and got this file system. And now I didn't have a squashfs file system. I had two new files, the bootdata1 and bootdata2.bin. And I didn't know what they were. But I looked at a different file that I found called mainDFL. It's probably just a bootloader configuration. And it says that the kernel, that bootdata1 is the kernel, and bootdata2 is the initRD. And the initRD is just like a really simple, it means just a really simple file system, like a RAM disk that the kernel can use while booting up. And it has all kinds of stuff that it needs while booting up. Basically, in a lot of routers and appliances like that, they use the RAM disk as their file system for all the important files, because they usually don't change this. And I guess that all the important files are inside the initRD because they weren't in all the other folders that I managed to extract. So I had to open it, the initRD. So I used the most common script to unpack an initRD, and it failed. I looked at the strings. Maybe there's something that will tell me what happened inside the file. Nothing. There weren't any strings. I looked at the headers. There were none. Was it random? Yeah, looks like it. And if you look at the entropy graph that Binwalk gives you, it's looked either encrypted or compressed. And I wasn't really into doing crypto stuff that day. So I said, well, fuck it. I'm not going to do it. I'm just going to find a workaround. So I changed my plan again. I knew I'm not working on the right version right now. So I let it go. I knew it's not the right one. I thought I'm going to find a vulnerability generic enough in the one that I managed to extract, in the firmware that I managed to extract, find an exploit for it, and maybe it will work on the one that the Tel Aviv city is using. So not soon after, I found the first vulnerability, which was a pretty cool one. This is the web server folders. And the web server can only serve files underneath a web CGI bin. This is the only place that you can serve files from. You can see the index HTML. And all the CGI's files are located inside the web CGI bin manga, inside that folder, all the CGIs that we've seen before. And it also, in the configuration file of the web server, it says that it can only run files, CGI files from this folder, from the manga folder. But there is another folder called hasync. And inside of it, there is, you can see it down here, there is a single file. It's a symbolic link called hasync CGI. And it points to a file inside the manga folder, a CGI box CGI file. Now, if I'm going to surf to that file on my web browser, I know it can be executed, but what it does then? Well, it lets you download it. So that's great. So I went to that file and downloaded it. And now I have the original file from the Tel Aviv city, load balancer. It's the CGI box.cgi. It's an x86. The firmware that I managed to open was a MIPS architecture. And that file is the holy grails of all the files on that file system. Because as a researcher, this is the file I want to research. Because it's like the busy box of the CGIs. You can see that all the CGIs that you see on that folder are just symbolic links to that file, to CGI box.cgi. And when you execute one of those CGIs, then it executes the CGI box CGI and behaves according to the path that called it. So this is what I wanted from the first place. And I didn't have to open the firmware that was packed somehow to get it. That's pretty cool, so I did this. I looked at some strings, started reversing it, and I found it was compiled with something called libcgi. And I got the sources, and it really helped me for, not sure how many of you ever tried reversing or do it on a daily basis, but reversing is pretty hard sometimes. Usually if you don't have strings, if you don't have symbols, if you don't have sources, because I tried to put this picture, I don't know why. If you try to reverse with no strings, no symbols, then it looks something like this. But if you have sources, then reversing looks like climbing on front of this. You have all those colorful stuff to hold on to. So it really helps. And now I made my fourth plan. I know I have to reverse the CGI box. That's the file I want to reverse. And I have the right one, right? So I started reversing it. And when looking at the attack surface, I tried to look, what can I call, what can I do without being authenticated, because I didn't have any username or password. So what can I do? And basically nothing. But I found one file called API IC2 CGI that allows you, I think it's supposed to allow remote login for sysadmins. I'm not sure. I didn't actually look for what it does. It lets you to log in and allows you to log out without being authenticated. Now, the login was pretty solid. They actually checked it for vulnerabilities, probably. I didn't find anything. But when I looked at the logout, that's the code for the logout, I found 2 new vulnerabilities. I'm not sure if you can see it. Well, the first one, you can see there is an SQL query that it tries to build. And it gets some of the parameters into the query from the value of a cookie that I control. Try to just find you in a DB and removes you from there. And the second vulnerability is here on this sprintf, because it's trying to build this query inside a buffer called, where is it? str final query. Can't see. Here. It's trying to write the query inside this buffer, and it just copies as much memory that you give it. You give it just a buffer overflow. You just give it a lot of memory. It just writes it into the memory. And if you look at what str final query is, just a place in the static memory, and you can just run over from this place to wherever you want to. No validation before. And if you go to str final query plus 14E47 hex, then you can find the global offset table. And it could be great, because if I can run over all that data from here to here and just run over some of those functions with pointers that I control, then I can control the flow of the program when one of those functions is called. The problem is that 14E47 hex is pretty long. An exploit could look something like this. This is how the exploit could look like. Well, and Bar said not to share POCs, but sorry about that. So this is a POC. I just have to send this. But the boff value should be pretty long. And I wasn't sure if it's going to work. So I had to try, and didn't want to try it on the real thing, because if I'll try it on the real thing, I might crash the entire internet for entire city, or a lot of tourists trying to use Tinder or Facebook something. I didn't want to do it. So I had to build a working model at home. So it was time to unpack the 380. It was time to face it. So a little recap. We had the boot data to bin. According to the many DFL, it's an init.rd. And the entropy said it's either encrypted or compressed. We have to do something about that. So I didn't know a lot about int.rd. And so I went to the kernel code that handles int.rd. And you can see that what it does, just go to the first block, checks what is the best decompression method, and use it. Look in the same function at Pepling's code in their kernel, the bootdata1.bin. You can see that it has some XOR instruction in it that you can't really see here because there are none. So they added this really simple XOR encryption to some of the fields inside the int.rd. So just wrote a couple of Python lines, short script that goes over the firmware and encrypts it. And now you can see a working model with an IP address inside my house. It's an actual model working in my house. And I wrote my exploit, tried it, and it didn't work. Happens. And that's it. Sorry. So it didn't work because HTTP headers can be longer than 64K in that particular web server. So that really sucks. So I kept poking around, and I found a second separate CGI called firmware CGI that isn't linked. It's not a symbolic link to CGI box, but it also uses libcgi for its infrastructure. And here the str final query is only 184 hex away from the GOT. So look in the memory layout, it looks like this. And if I want to exploit it, then exploit is going to look something like this. Really simple. Well, I wanted to do a demo, and then somebody came to me and said, don't do it. So this is the only thing I can say about my demo. Not going to incriminate myself. So I wrote a short post blog on my blog, and left there for a couple of days. And then I got a mail from somebody. I called him the Ukrainian hacker. He started sending me emails, really weird emails that he probably wrote in Google Translate. Started with, hello, dear friend. I found your investigation related to Pepling 380, Started giving me all kind of weird excuses why he needed my vulnerability, why he needs to do a POC, all kind of weird stuff. And at that exact same week, Russia just invaded Ukraine, and I didn't want to find myself giving working exploits to Ukrainian hackers to hack Russian infrastructure. So we just kept on talking, told him sorry. He was pretty upset. He wrote something that I'm not sure it's even in English. But that's it. The company, I wrote an email to the company as well. And they were really shocked. They said, whoa, how did you break our encryption? I actually talked to their chief engineer. So, well, that's not an encryption, sorry. And we talked about how to fix some of the problems, found a couple of other bugs during the way. And they were pretty shocked because they never thought somebody can do something like this. So they sent me a load balancer as a gift. I just used the holder for my Body Christ doll. I'm not really sure what to do with it. Just does a lot of noise and heats up the room. And that's it. Actually, it was pretty fast. right, I have to finish my shot.
Finishing early, you get another shot.
All right? Woo. תודה, תודה.
Does anybody has any question? No questions here?
Yeah.
What kept you motivated after so many failures?
Sorry?
Please repeat the question.
Yeah. What kept me motivated after so many failures? I was bored.
It must not be that box, right?
Sorry?
It must not be that box you got.
No, didn't know I'm gonna get it until the end. Well, I'm not really sure. I was pretty bored. It wasn't my girlfriend that told me just close the computer, go to sleep. What the hell are you doing all the time? I don't know. Probably it was the unbreakable VPN that got me mad. I don't like smug people or smug companies.
You have one more question down there.
Where? Yes.
You didn't log into the Wi-Fi?
Sorry?
You didn't log into the Wi-Fi webpage?
If I'm not really sure, did I log into the Wi-Fi web page?
The Tel Aviv city login page?
No, because I have an exploit. I don't need to know the username and password.
Did you exploit it? Try to get
Yes, I want to go to jail. Right?
So I guess
Yes.
I guess they have released, they have upgraded the firmware, released it, etc., etc. Do you know how fast it was deployed on the Tel Aviv infrastructure or elsewhere?
Sorry, say it again.
Do you know how fast it was deployed on the infrastructure that's of, let's say, Tel Aviv?
Oh, you mean the patch?
Yes.
How fast did they deploy the patch? So the company wrote a patch. I think it's firmware 6.12. That's the name of the version. I think I have a thank you there. They told me that they managed to patch most of their products around the world to this vulnerability. I'm not really sure if they patched the entire network in Tel Aviv. We can try it. We can't.
Can you put your slide with your contact details if people want to talk to you?
Yes. Well, I don't have a slide with contact. The first slide.
Hey, then I'll find you.
All right. So you can find me here, but
Here in Tel Aviv.
yes. So this is my name. Like I said, I work for Ecos Technologies, and if somebody wants to talk to me afterwards, you can come. Yes.
Relating to the first question,
Yes.
how much time did it take you from finding the public space Wi-Fi to actually creating a proof of concept? How much time did it take?
I think the overall time was something like 10 hours, maybe a little more, maybe 2 days. I don't really remember. I think you can see that I came home at 3 o'clock. I'm not really sure why, by the way. Yeah, but I was on my way home. That's what I remember. So I guess it took me like the whole day from that point, and some the night, and some the other day. So now out of time. Yes? Yeah. Sorry?
Repeat the question.
Did I get any legal opinion if it's illegal or not? Well, I called my dad because he's a lawyer, and I got really excited. Well, I managed to hack the. Well, I did something, and is legal or not? So I just told him. I guess if it wasn't really not legal, then he will tell me something. Otherwise, that's all the help I got legal-wise.